calculator to get the answer. We're going to do the same examples here. Word problems, equations, and then software to solve. And because we have softwares, we are no longer limited to just 3x3 matrices. So now we can do 4x4s, 4x6, 5x5s, 6x6s. And that's what you're going to kind of see today is more extreme situations, but technology is going to answer it. The hardest part you have to do is write the equations. So let's read this example here. It says, bless you. It says a scientist measured the greatest linear dimensions of several irregular metal objects. He then used water displacement to calculate the volume of each of the objects. The data he collected are 1, 3, 2, 5, 4, 9, 6, 20. Those are coordinates. So coordinates are usually what letters? X and Y. All right, keep that in the back of your mind. Where the first coordinate represents the linear measurement of the object in centimeters, and the second coordinate represents the volume in cubic centimeters. Knowing that the volume measures generally vary directly with the cube value of linear measurements, he wants to try to first fit this data to a curve in the form of this. When you are doing like SAT or ACT type questions, when you have word problems, a couple things you should like just have your brain trained. Identify any equations. So here's an equation. So this is going to be important. And then identify any numbers and then see what those numbers are associated with. So those numbers are associated with the measurement of the object in centimeters and then the volume of cubic in centimeters, just knowing what those variables mean. Those are to be like the things you should be able to pinpoint, ideally on any type of test, even with mine or college placement exam, especially with the ACT tomorrow. All right, so with that all said, if I know these are coordinates and they're labeled typically as X and Y, this right here are X's. What is Vx a fancy way of saying? A Y. So I can actually produce 4 equations with just this information alone. And this is how. If I look at 1, 3, I'll just plug in 1 for all of my X's and 3 in for my Y. And when I do that, I would get 3 equals, what is 1 cubed? Just 1. So this becomes 1A. Or just A. What's 1 squared? 1. So this becomes 1B. Plus, what is, well, just 1. Well, just 1. So I'll just put a 1C plus a D because I don't have any X there to plug in that 1 value. Now, one thing I like to switch up to keep in our form is I'm going to put that 3 on the right side. Now, why would I put that equals 3 on the right side? Because what does that matrix represent typically? So when we make our 3 matrices, what is the equals to numbers typically? What matrix? I got a test on Wednesday, guys. But we want to write our equations in the form of LX equals B. I am. So the numbers that are on the right of the equal sign represents my B, but I always had it on the right side. So I just wanted to rewrite it so the equals numbers was on the right. Yes, ma'am? And then use technology to solve. Absolutely. That's it. Yep. The hardest part is just forming the equations. After that, the technology does the rest. All right, so maybe you didn't see the pattern here. So let's make the second equation together. I'm now going to use the coordinate 2, 5. So I'm going to go ahead and say equals 5 right here since that's what my y is. And now this time I'm going to take 2 and plug it in. What is 2 cubed? 8. 2 times 2 is 4. Times 2 again would be 8. So that'd be 8a plus what is 2 squared? 4. So this becomes 4b. And then 2 is just 2. So it becomes 2c plus d. Do y'all see how I'm doing these numbers and not just, all right, go ahead and come up with the next 2. There's a D. There's a D there. There's just no X. So on a matrix, what would you write for the coefficient of D each time? 1. Very good. So come up with the next two equations. The number equals. Yeah, that's how I wrote it originally. The only reason I switched is because I'm going to have to need it in this form. Now, if you know that that number equals this is still your B and you don't get confused, I'm good with that. Do we already have the two other equations? All right. So then to quickly kind of go through this, 4 cubed would be 64A. 4 squared. Good. And then good. Perfect. And then we move on to the last one. What is 6 cubed? Perfect. Any questions on to form those equations? Again, that's probably the hardest challenge there. But again, identifying equations, numbers, what's the numbers mean, can get kind of guide us towards where we need to approach. Now it says it wants us to represent this as AX equals B. So my A would look like what? Okay, down. That's fine. 8. That's a B. 1. Perfect. All right, so that's your A, and you can go from left to right or top to bottom. It don't matter to me as long as you got them in the right spot. What would my X represent in this situation? It would be A, B, C, D. Now, if it didn't give us letters, and you had a 4 variable situation, just so you're aware, it usually goes X, Y, Z, W is the next letter if we choose. Well, yeah, yeah, I guess, yeah, I see what you mean there. Equals, now what's my B matrix going to be? Good. Any questions on that? So again, I feel like this is the hardest part, and then y'all can transition pretty well after that. So we're good? Is that a or no? Okay. All right, so now we're going to use that to help us solve. So it says use technology to solve this. So um to give you an idea how you do this, if you weren't here on whatchamacallit, what day was that? We did that Thursday? If you weren't here Thursday, to solve for B, you would have to take the L inverse of no, not my bad. To solve for X, my bad. You would have to take L inverse of B. Right? Now, we learned how to do L inverse of a 2 by 2. That's expected out of you. Anything greater than that, we can just use our technology. So what you would do is you would take that giant equation you just formed, which was 1, 8, 64, 216, 1, 4, 16, 36, 1, 2, 4, 6, 1, 1, 1, 1. And you'll type that into your calculator with a -1 as an exponent to represent the inverse times the B. Big thing, just like on the 2 by 2s, this has to be on the left side of your B. And this was 35920. So now I'm just going to type that into the calculator. Yes, sir? Why? Because that's going to represent the inverse. So remember, originally the equation is LX equals B. If I want to solve for X, I have to take the L inverse of both sides. So what I'll do is I'll go L inverse like that. This right here technically turns into the identity matrix. So therefore now I'm just left with this L -1 inverse. Yep. Now, once you have this written out or however you have it, now we can go plug this in. So I'm going to delete it for right now, but it'll come back here in a second. We learned a quicker way to get there, either I think at the end of this class period. I think Ari had pointed it out. There's a button right next to the 9. And then there's still a I call it a waffle, but it's a 3 by 3 matrix. So hit the button next to the 9. And then if you hit the 3 by 3 matrix there, it'll allow you to change how many rows and columns you have. So how many rows and columns does this matrix have? 4. We also learned, I don't know if it was this period or last period, but instead of hitting the down button, watch what happens when I hit down, it changes the number. So once I hit that 4, if you actually hit right again, then you can go. Oh, wait, no, it was tab. Sorry, tab. If you hit tab, then it'll shoot you to the next number. Then you can hit 4, then tab again, and then you can hit enter for OK. Versus hitting that up and down button that will actually change the variable. Then all you got to do at this point is just type in all of those numbers. So again, that was 1, 1, 1, 1, 8, 4, 2, 1, 64, 16, 4, 1. Better than doing it by hand. 216, 36, 6, 1. And then once you have it typed in, if you then hit that rooftop button over there to the left of X squared, it won't let me. There it goes. All right, so you hit that button. It makes a little bitty square up there. Type a -1. Makes it the inverse. Hit enter. It gives you these fractions. Now, what I should have done, after I hit that inverse, I need to go ahead and plug in that B matrix. So now I'm going to come over here. I'm going to do this, and then it would be, what's the B matrix considered? A 4 by 1. So good, it gives you the right shape, so good. 3, 5, 9, 20, 3, 5. Uh-oh. 3, 5, 9. Come on now. 20. And there you go. Now, those are decimals. Let's see. So use technology to solve the system. We did. Based on your solution, write this as a cubic equation. You could technically, if you wanted to, you could turn these into a decimal. And the way you can do that is if you just hit menu 2 for numbers, convert to decimals, or menu 2 1. enter. You get those same answers, but just now in decimal form. It really doesn't matter to me which ones you go with. I do think the decimals look a little bit cleaner for this situation, but you would be right in either using decimals or fractions. Go ahead. So menu, 2 for numbers. Nope, you don't have to. Yep, and then 1 to convert to decimal. And then hit enter, and it should do it. Did it do it? Okay. Yeah, so either way works. I'm actually okay either way, but had a question asked round your answer to 2 decimals, you would need to turn them into decimals so that you are able to round. All right, so if I bring all that back, you've now solved it. That was part C. Part D says, based on your solution to the system, what cubic equation models this data? So now this is what you would do. So I'm going to write it here in this blank space. But D, to write this equation out, you originally started with V of X equals AX cubed plus BX squared plus CX plus D. What do these 4 numbers represent? The 4 numbers that we got as our answer. A, B, C, and D. So since you got A, B, C, and D, all you got to do is now plug it in. So V of X would equal 0.175x cubed minus 1.225x squared plus 4.45x minus 0.4. Wasn't like I was using it or anything. Son of a gun. I have no idea. Am I still recording? Oh, super weird. It says, okay, I guess I'm still recording. You'll still see it up there? It won't let me go back to it. All right. So do I need to rewrite that again? Okay, so part D again was just those answers either in fraction or decimal form. All right. Then in part E, it says, what are some limitations of the model? So the model is what you just got on part D. So what would be some limitations to this model? It's ugly. It's cubic. So what's a cubic model look like? Anyone know? A cubic function. That's what a cubic function looks like if you don't remember. But it says some limitations. Again, this is kind of hard to kind of tell. But the cubic function is just a model of something that goes through those 4 numbers. Depending on the rest of the results, you could then predict things out of that. So limitations. Does it give it to you as this as well? No. You can to kind of see what you kind of be restricted. It is limited to the 4 points given. So, I mean, if you're trying to predict something, you could use that to predict. It could be skewed or whatever the situation might be. All right. Not a big fan of that question E. All right. What I want you to do now is look at exercise 1 and see if you can now write a matrix off the information given. So represent a relationship that reflects the annual movements of students among the elementary school using a matrix. Start off with the equations and then transform it into a matrix. I'll give you some time to attempt. Yeah, it has a little bit of a hump there, but yeah, but it only predicts for those 4 points. So depending on the data that we're trying to predict or whatever, it could skew it one way or the other. A Part E, in my opinion, is a great model for what was given to us. I would look at those sentences with some numbers in there. Percents or numbers? How do you turn a percent into a number? Mm, We're 8 weeks from that. Actually, you're juniors, right? You're 9 weeks from that. There's apparently 11 weeks in this 9 weeks. Yeah. Yeah. Well, when we got back, we had 44. And only if you divide that by 4, that's 11 weeks. I gotta get out of that. To come up with the equations. Well, let's look at it, analyze it. So it says an attendance officer in a small school district noticed a trend among the 4 elementary school districts. How many equations do you think I'm going to have? Probably 4. This district used an open enrollment policy, which means any student within the district could enroll at any school in the district. Does that really give us any information? Not really. Yeah. Each year, 10% of student 10% of students from Adams Elementary enrolled at Davis Elementary, and 10% of the students from Davis enrolled at Adams. In addition, 10% of students from Brown Elementary enrolled at Carson Elementary, and 20% of students from Brown enrolled at Davis. At Carson Elementary, about 10% of students enrolled at Brown and 10% enrolled at Davis, while at Davis, 10% enrolled at Brown and 20% enrolled at Carson. The officer noted that this year the enrollment was, bless you, 490, 250, 300, 370 for Adams, Brown, Carson, and Davis, respectively. All right, so let's see. Yeah, no, too much switching. All right, so here we go. So let's write some numbers. I'm going to let this be my XYZ W. I need my 4 variables to have a variable rather than names. So I'm just going to go with X, Y. Sure. Okay. Yeah. Okay. Let's do that. If you don't like the way I did it. No, it's fine. So you made your point. Just kidding. A, B, C, D. Right. Heck, if you wanted to, you could do A, B. Oh, look, it actually is alphabetical order. I didn't even notice that. All right, so but we're gonna let A be Adams. We're gonna let B be Brown. We're gonna let C be Carson. And we're gonna let D be Davis. So now that just means every time I see those words, I can now associate it with a variable. All right, so we first got each year, 10% of the students from Adam Elementary enroll at Davis Elementary. So if we start off with Adam, which will be my A, CSC, each year, 10% of the students at Adam Elementary enrolled at Davis Elementary. So with that, we can say, no, because we know that 10% of them went, because there's a lot of moving around. So for Adams, they would basically have 90% of their students left. Well, we'll represent that with a decimal. So 90% of their students left. So 10% of the students from Adam enroll at Davis. So yeah, so 90% of them stayed, yeah. So then Davis, I don't know how many they have, but I know they went, oh, okay, hold on. Hold on. I think I have an idea. If the first equation is going to represent equals, okay. This will equal 490, 250, 370. I lost a number. 492. Oh, 300. 300, 370. And this is Adams. So okay, so for Adams, I know I have 90% of my kids. And then for Davis, so this would be the last one. I think this will be 0.1A. So out of my original Adams Elementary, 90% of them are still in Adams, but now 10% of them has now gone to Davis. That's about as far as I can go with that. And I don't think you'll ever see one this hard on the SAT or ACT. So we have 100% in Adams, right? 10% of them goes to Davis. So 10% of Adams went to Davis. So that means 90% of Adams is still part of Adams, according to just that first sentence. All right. 10%. Okay. Now 10% of the students from Davis enrolled at Adams. Okay, so that's so crazy. Okay, so 10% of the students from Davis are now at Adams. So now this still makes up 10% of Davis, which then means I still have 90% of Davis still at that school. All right. And I'm trying to keep it in the same order of A, B, C, D. Okay, so that's that first sentence. Are you ready for the next part? In addition, 10% of students from Brown enrolled at Carson. So that means that 10% of Brown is now at Carson. So that would then tell me that 90% are still at Brown. So again, 10% of the students at Brown enrolled at Carson. So I still have 90% of Brown. And then it says, and 20% of students from Brown enrolled to Davis. So now I have 20% enrolled in Davis. But this is going to knock this percentage down to 70. Okay. Well, this is a good one. We will, yeah. Yeah. So there'll be a plus sign here, plus sign here. Man, looking at this, I guarantee you these columns, I bet have to equal one at the end of this. 'Cause that's what we're kind of floating around. Like this right here is one, this is one, this is one. So we're gonna have to like subtract, take away, and move things around as we find out more information. Okay, so where were we? All right, so Davis enrolled at 10%, in addition, 10%. All right, so we were here. So 20% of the students from Brown, so we subtracted two more, put them to Davis. At Carson Elementary, about 10% of the students enrolled at Brown and 10% enrolled at Davis, while at Davis. Whoa. So at Carson Elementary, we have about 10% of the students at Brown, which we already have. 10% of students from Davis. So that means this needs to go down to 8. While at Davis, 10% at Brown. But we already have that. Did I already say that? So 10% of students at Brown and 10% enrolled at Carson Elementary. About 10% of students enrolled at Brown and 10% enrolled at Davis, while at Davis. Why is that trickier in words there? So it says, so at Carson Elementary, 10% of the students enrolled at Brown. What do y'all got here? This is a vocabulary here. So at Carson, okay, what you get? So it says Carson Elementary, about 10% of the students enrolled at Brown and 10% enrolled at Davis, while at Davis, 10% enrolled at Brown and 20% enrolled at Carson. Yeah, that sentence is killing me. 20% enrolled at Carson. Ten percent of students enrolled at Carson. 10% of students enrolled at Brown and 10% enrolled at Davis. Oh, okay, hold on. So at Carson Elementary, 10% of them enrolled in Brown. So that would be 0.10C right here. And 10% enrolled at Davis. So that'd be 10D here. Oh, 10C, sorry, 10C here. Plus sign here. Plus sign, plus sign, plus sign, plus sign. Okay, that's where I'm at right now. Oh, thank you. It's represented A, B, C, and D. Oh, I don't know. No. The columns, I think, are going to equal 1. Because this column here is going to represent all of original atoms now dispersed. This is going to represent all of Brown's now dispersed, all of Carson's, all of Davis. So this is where, okay. Oh, man. All right, so 10% of them went to Brown, 10% of them went to Davis. Now, while at Davis, 10% enrolled at Brown. So at Davis, so while at Davis, 10% enrolled in Brown. So while at Davis, which is here, 10%. That second sentence is killing me. So, okay, so 10% of students went to Brown, 10% went to Davis. Got that. Now we go, while at Davis, so now we're at Davis Elementary, 10% enrolled at Brown. Oh, okay, so this would be 0.10 over here. So 10% of Davis went to Brown, 20% enrolled to Carson. So here's Carson. So while at Davis, 20% enrolled at Carson. So here's Davis. So 20% enrolled at Carson. Well, this is Carson here. Okay, so that would mean that this goes down to 60 now. And that 20%. The 20%. So while at Davis, 10% enrolled at Brown. And 20% went to Carson. I'm just lost on that last one. Where's that last number go? That's what I don't get. So it says while at Davis, 10% enrolled in Brown. I get that. But then it says then 20%. So that's another 20% taken away. Need to go to Carson. So does this become 0.3? At Brown. Oh. Okay, so that 0.2 here would need to be added to the Carson side. What'd you get? I guess 20. Okay. Okay, because this will add up to, yeah, so this right here would have to add up to 1 as well. So that'd be 7, 8, 9, 10. Okay, I got you. So this would be 0B plus 0C. This would be 0A. This would be 0A. And this is the part I don't get. Okay, then that would make this okay. But then this here is only, all right, where'd you get that second 10%? So it came from Davis to Brown. Oh, is that what this would mean then? The 10% rolled to Brown. So it happened again? Oh, so Davis and Brown got 2 more percent. That's how this knocked down to just 6. Woo. Yeah, but that wouldn't add up to 100%. It's supposed to do both. Man, is the words. That's the only question mark I have there. I get the 0.8C now because this has to add up to one. But this was 0.7, 0.1, 0.1, and that became point D. Man, I will say on the test you won't have something this complicated, but you do need to kind of practice the idea of turning words into math problems. Correct, yeah.